Our topic today is all about conditions and properties which guarantee that a quadrilateral is a parallelogram. Okay, so there are five conditions. Number one, a quadrilateral is a parallelogram if both pairs of opposite sides are congruent. Number two, a quadrilateral is a parallelogram if both pairs of opposite angles are congruent. Number three, a quadrilateral is a parallelogram if pairs of consecutive angles are supplementary. Number four, a quadrilateral is a parallelogram if the diagonals bisect each other. And number five, a quadrilateral is a parallelogram if each diagonal divides a parallelogram into two congruent triangles. So these are the conditions that should be satisfied if a figure is a parallelogram. Okay, so let us now examine or visualize the condition and properties which guarantee that a quadrilateral is a parallelogram. Let us now examine the first one. We have a quadrilateral is a parallelogram if both pairs of opposite sides are congruent. Okay, so let's identify first where is the opposite side here. Okay, so the opposite side here is WX or line WX is opposite to line ZY or side ZY. And also the other opposite, since we're talking about pairs, there are another one. We have the side WZ is opposite to XY. We have the XY. So those are the opposite sides of the quadrilateral WXYZ. Okay, based on the condition, if both pairs of opposite sides are congruent. Like for example here, this is the opposite. We have so WX. Let's have a values for them. Okay, let's have a WX have a measurement of 45 meters. Okay, so if that is 45, this side or the opposite side also have a measurement of 45 meters. And also if this is 20 meters, the opposite side also a measurement of 20 meters. That is the conditions. That is how, okay, if you satisfy this condition, therefore this shape is a parallelogram. So if a quadrilateral is a parallelogram if both pairs of opposite sides are congruent. So if those opposite sides are congruent, therefore that is a parallelogram. Okay. So that is the first condition. May we have the second conditions or properties of a parallelogram. Number two condition, a quadrilateral is a parallelogram if both pairs of opposite angles are congruent. Okay, so let's identify first where is the opposite angles. So we have here the opposite angle is angle C is opposite to angle X, and angle W is opposite to angle Y. Okay, it says that in the condition both pairs of opposite angles are congruent. Okay, remember that the total measurement of the angles of a quadrilateral is 360 degrees. Have a measurement of 360 degrees. So therefore, this 360 will be divided into 4. Okay, so let for example here. Okay, so if this will be okay, 100 degrees. Remember the units for the angle, that is degrees. Okay, this will be a measurement also of 100 degrees. As I've said, as I've said in the uh, as I've said on the a while ago, that uh, the opposite angle, or based on the condition, the opposite angle are congruent. So this angle W and angle Y are congruent. And if this is what they call that 100 or 100 degrees, okay, this will be 100. Okay, so still we have still a so since it is 100 degrees, we need more to be able to exact 360. We have still 160 degrees that will be divided into 2. So this will be have a measurement of 80 degrees and also 80 degrees. So based on the condition, a quadrilateral is a parallelogram if both pairs of opposite angles are congruent. So as you can see, this angle W is congruent to angle Y, and angle Z is congruent to angle X. Okay, so that is the condition of a parallelogram. So so, so this is how, okay, the condition says. Okay. Okay, may we have example, not example, the condition number 3. Okay, so here is the condition number 3. A quadrilateral is a parallelogram if pairs of consecutive angles are supplementary. When we're talking about supplementary, okay, when talking about supplementary angle, this has a measurement of 180 degrees. When you're talking about complementary, okay, complementary angles, so it's a, sorry for the uh, messy writing. Okay, so when talking about complementary angle, this is 90 degree, just only a recall of your previous lesson. Okay, since we're talking about supplementary angle, okay, so this angle have a measurement of yes, a measurement of a total of measurement of 180 degrees. So based on the condition, if pair of consecutive angles are supplementary. So let's identify first where is the consecutive angles. So we have here, okay, so the consecutive angle is angle Z is consecutive to angle W. So meaning, okay, the total measurement of this one have a measurement of 180 degrees. And also we have here, okay, so angle W is consecutive to, okay, consecutive to angle X, and angle X is consecutive also to angle Y. Okay, so based on these are the consecutive angle are supplementary. Okay, based on our example a while ago, okay, we have a measurement of 100 here. The angle X, angle W have measurement of what they call that 100, and also the angle Y have a measurement of 100 degrees, and this will be 80 degrees, and this will be 80 degrees. So based on the condition, okay, so a consecutive angle are supplementary. Okay, so we have, as you can see, okay, if we add these two measurements, then a total of what you call that 180 degrees. As you can see, this one also, these are the what they call that a consecutive angle and a total of 180 degrees. And also this one, the consecutive angle, which is angle X and angle Y, have a total of 180 degrees. And also this one, angle Y and angle C is a consecutive angle with a total measurement of 180 degrees. Okay, remember that in assigning the values, okay, or checking the values or measurement of the angles, it should be a total of 360 degrees. As you can see, we have 180. Okay, so 180. So a total of that, we have 360 degrees. Okay, so 360 degrees measure of a quadrilateral. Okay, so that is, okay, so we can say now that this figure is a parallelogram because the consecutive angles are supplementary. Okay, so let's have the condition number 4. Okay, condition number 4. Okay, a quadrilateral is a parallelogram if the diagonal bisect each other. So if we, okay, based on the condition, if the diagonal bisect each other. So meaning, if we draw the diagonal here from X and diagonal from W to Y, okay, so the diagonal bisect each other, they intersect each other. So therefore, this is a parallelogram. Okay. So in a parallelogram, yes, in the what they call that in a parallelogram. Okay. So remember, the diagonal is what they call that also congruent. If this will be a measurement of what they call that 100 from here to here. Okay, this line also have a measurement of 100 if that is the measurement of the diagonal. So like for example, let's say 100 meter or 100 meter here also. Okay, so let's have the last one. We have the condition number 5. A quadrilateral is a parallelogram if diagonal divides a parallelogram into two congruent triangles. I repeat, if each diagonals, if each diagonal divides a parallelogram into congruent triangle. So if we draw a diagonal here, sorry for the, okay, so if you draw a diagonal here, it divides the parallelogram into two congruent triangle. So if this condition will be satisfied, therefore that is a parallelogram. If the figure will be, it divides, if we draw a, what they call it, a diagonal into a quadrilateral figure, and it divides the the parallelogram into two congruent triangle, therefore that is a parallelogram. Okay, so here are the types of a parallelogram. Here is the different types of parallelogram that satisfy those five conditions. Okay, so we have here on the chart of a parallelogram. From here we have a parallelogram. Then it divides into two figure, which is the rectangle and a rhombus. Okay, then from rhombus it transforms to it goes to square, and rectangle it goes to square. Okay, so let's examine them. Why those arrows from rhombus will be going to square and rectangle going to square also. Okay, let's examine. Okay, so from the rectangle, okay, so based on the, let's examine the definition. Okay, so the parallelogram is a quadrilateral with two pairs of opposite sides parallel. Okay, so based on the, okay, in the figure here, this is an example of a parallelogram. Okay, so a two pairs of opposite sides are parallel. So what are the opposite side here? Okay, let's say this is will be A, B, C, D. Okay, so where is the opposite side here? We have the side AB is opposite to side DC. So opposite, and opposites, two pair of opposite sides are parallel. So side, okay, side AB and side DC is opposite side, and they are parallel. When we're talking about parallel, these two line, okay, these two line are not even you extend that one, that will never intersect. That is a parallel line. Like for example here, if I draw this one, if you extend that one and extend that one, they never intersect. That is what we call a parallel lines. So here, so the sides, side AB and side DC, if we extend that one, they never intersect. So there are parallel, and they are also opposite sides. So another opposite side that is parallel is line AD is opposite to line BC. If you extend that one, even you draw a line here, they never extend, they never intersect. Even here, even you extend that one, extend that one, they never intersect. So that is a parallel lines. Okay, so that is for the parallelogram. So now here is the the three types of a parallelogram. Okay, we have here the rectangle and the rhombus. Let's examine. Okay, what are the characteristic of a rectangle? When you're talking about a rectangle, a parallelogram with four right angle. So it is a parallelogram. Why? Because the sides are, even you extend that one, even this one, their sides, they never intersect. So therefore, it is a parallelogram. Now, the characteristic of a rectangle is with the four right angles. Okay, so here have a four right angle. Okay, so when we're talking about right angle, a right angle has a measurement of 90 degrees. So if we have 90 here, 90 here, 90 here, still Okay, so if you add that one, the total of 360 degrees. So the characteristic of rectangle has a uh, have a four right angles. Okay, so say we're done with the what they call that, the rectangle. Now we will now moving to rhombus. Okay, so let's examine the why it become a parallelogram, this one. So if we extend this one, the side of a rhombus, okay, they never intersect. Even here, we extend the opposite side there, okay, they never intersect. Now, based on the definition, rhombus is a parallelogram with all four sides are congruent. Okay, so all sides of the rhombus is congruent. So this one. So this is a symbol for a congruent. Okay, so four sides are congruent. If the sides have a measurement of 5 meter, then this also 5 meter. 5 meter, this one also, and this will be 5 meter. So that is the characteristic of a rhombus. Okay, so all sides are congruent. While this one, all angles, we can say that also all angles are congruent because they are a measurement of 90, and it's all we all know that is a right angle with a measurement of 90. Therefore, these four angles of a rectangle is congruent, but its side is not congruent. Not all, but the opposite is congruent. Okay, so okay, so that is the rhombus. So compare this one. So this rectangle have measure the all angles are congruent, and this one, the rhombus have a the all sides are congruent. Now we're now moving to square. So when we're talking about a square, a rectangle with all four sides are congruent. So all sides of the square is congruent. It is a for a rectangle also, but difference is all sides of the square is congruent, and all angle of the square is also congruent with a measurement of 90 also, which is similar with the rectangle. Okay, so therefore, so that's why the arrow is going to square from both the rectangle and rhombus, because square possess the characteristic of the rectangle and a rhombus, which is a square is a what they call that, have a congruent side and congruent angle, which is possessed by rectangle and possess the rhombus. Okay, remember that one. Okay, so let's have the okay, so let's apply the properties of parallelogram in identifying the measurement of those sides and angle of a uh, parallelogram. Okay, so let's name this parallelogram A, B, C, D. Okay, so the given is, okay, line AD, sorry, that will have a line. Line AD have a measurement of 40 cm, and line yes, it's line AB have a measurement of 50 cm. Okay, so let's identify, and the given, another given is angle B have a measurement of 80 degrees. So let's say this will be 80 degrees. Okay, now let's identify the measurement of the parallelogram. So based on the 5 conditions, okay, so the opposite of the line AB is congruent. Okay, so therefore the opposite side is line DC. So therefore, if this is 50 centimeter, this also is a 50 centimeter. Now, another is, so we have the given line AD is, okay, let's line AD, yes, line AD, opposite side is line BC. So if line AD is opposite with the line AC, I should say, AC, so therefore, this line, sorry, this BC, I should say, line BC is also have a measurement of 40 cm based on the condition a while ago. So this will also have a measurement of 40 cm. Okay, so let's say this will be 70 because we already used a while ago the measurement of 80. Let's say this is 70 degrees, not 80. So this will be 70. Okay, so if this is 70, based on the condition, the opposite angle is congruent. The opposite angle is congruent. So the opposite angle of what they call that line, angle B is what? Angle D. So if this uh, angle B have measurement of 70, this also have a measurement of 70 degrees. Remember the units. Okay, so now how we identify the measurement of these angles? Okay, since it is 70, based on the condition, the consecutive angles are have a measurement of 180 degrees, or what we call a supplementary. So therefore, if this is 70, what will be the measure of this one? So we need to, from since we have angle A plus angle D is equal to 180 degrees, isn't it? Okay, so let's substitute the given. So since it is angle A is the missing, angle A plus we have what? Angle D with a measurement of 70 degrees. So we have 180 degrees. Where do I get 180? Because we all know that it is supplementary, so therefore I use it. If we add the two angle, have a measurement of 180 degrees. Okay, so we have angle A. Since we cannot add this one, we will transfer to the other side. It becomes angle A is equal to 180 minus 70 degrees. Then angle A is equal to 110 degrees. So 180 minus 70, it is 110 degrees. So therefore, this is 110 degrees. Okay. Now, okay, let us find now the what you call that measurement of angle C. So what is now the measurement of angle C? Since angle A is opposite with the angle C, therefore what? Angle C here also have a measurement of 110 degrees because based on the condition, the opposite angle is congruent. And therefore, when you're talking about congruent, therefore they have similar or the same measurement. Okay? So when you total this one, so as you can see this one, we have 110 plus 110 plus 70, that is 180 degrees. So 170 plus 110, that is also what they call that 180 degrees. If we add that one, a total of measurement of what 360 degrees, which is the measurement of a quadrilateral. So that is how we find the missing angles and sides of a parallelogram. Okay.
For more videos on mathematics, please don't forget to subscribe.